Hello my dear students, good evening to all of you. Welcome to my channel. Today I am going to discuss about types of wave. First of all, I am going to divide wave into two parts on the basis of requirement of material medium. First one is mechanical wave and second one is non-mechanical wave. Now I am going to define mechanical wave. What is mechanical wave? The wave which requires any material medium for its propagation is called mechanical wave. Mechanical wave requires any material medium for its propagation. But second one is requires no material medium for its propagation. First one is mechanical wave. Mechanical wave requires any material medium for its propagation is called mechanical wave requires any material medium for its propagation. The wave which requires any material medium for its propagation is called mechanical wave. Such as for example sound wave, wave on a string, wave on a water surface. If there is no material medium, then mechanical wave can never travel. As for example, if you go to the moon, then if you speak, then a person standing near to you does not hear, because there is no atmosphere present on the moon. On the moon, there is no atmosphere. Therefore, you cannot hear any sound emitted by other person. Okay? Now I am going to define non-mechanical wave. What is non-mechanical wave? The wave which requires no material medium for its propagation is called non-mechanical wave. The wave which requires no material medium for its propagation is called non-mechanical wave. Such as light wave, radio wave, etc. means all electromagnetic wave. It can be written as EMW. EMW means electromagnetic wave. All electromagnetic waves require no material medium for their propagation. But mechanical wave requires any material medium for its propagation. All electromagnetic waves require no material medium for their propagations. Okay? All electromagnetic waves are of transverse nature. All electromagnetic waves are of transverse nature. A speed of all electromagnetic wave in air or free space or vacuum is 3 cross 10 to the power 8 meter per second. In vacuum, there will be W, not double C. Refractive index of air is approximately equal to refractive index of vacuum, which is equal to unity. Therefore, a speed of electromagnetic wave in air will be approximately equal to a speed of electromagnetic wave in vacuum. Refractive index of air is 1.003, which can be written as 1 approximately. Therefore, a speed of any electromagnetic wave in vacuum and air are same. Now I am going to explain electromagnetic wave. What is electromagnetic wave? The wave which requires no material medium for the waves which require no material medium for their propagation are called electromagnetic waves. Okay. Therefore, non-mechanical wave is also called as electromagnetic wave. In electromagnetic wave, electro for electric field, magnetic for magnetic field. In electromagnetic wave, electric field and magnetic field both oscillate perpendicular to each other. Suppose E oscillates along x-axis, then magnetic field will oscillate along y-axis, and the propagation of wave will be perpendicular to both, that is in z direction. Okay, this is relation among electric field, magnetic field and a speed of electromagnetic wave. E is equal to bc. You can remember this formula by this trick. EBC, extremely backward class, or you can say engineer Vinod Chandra, or you can say engineer Baklol Chandra. Okay. Anyway, this is if E represents electric field, B represents magnetic field, and C is the speed of electromagnetic wave. Now I am going to discuss terms associated with wave motion. Terms associated with wave motion. Terms associated with wave motion. What is amplitude? The maximum displacement of an oscillating particle from its mean position is called amplitude. Maximum displacement of an oscillating particle from its mean position is called amplitude. Amplitude is the maximum displacement. Therefore, the nature of amplitude will be vector or a scalar. This will be vector quantity. Amplitude will be vector, and its SI unit is meter, CGS unit is centimeter, because it is maximum displacement. The unit of displacement is meter or centimeter. Therefore, a unit of amplitude will be also meter and centimeter. What is the dimension of amplitude? Dimension of amplitude will be same as the dimension of displacement. Both are same, because amplitude is the maximum displacement of oscillating particle from its mean position. What is mean position? The position of an oscillating particle at which net force acting on the particle is zero is called mean position. Mean position is that position at which net force acting on the oscillating particle is zero. Suppose this is simple pendulum and this will be mean position, because if you draw free body diagram at this point, then a string pulls and this force will be gravitational force, and tension in the string balances gravitational force, that is T is equal to mg. Therefore net force acting on this position will be 0. Therefore this position is called mean position. Suppose a spring is connected to a block whose mass is m, and here surface is smooth. If surface is not smooth and air is present, then its amplitude is gradually decreasing. But we have to study that case in which there is no friction and there is no air particles. This means work done by dissipating forces will be equal to 0. Therefore, if you pull this block towards this, then if you pull this block towards this and then you release, then what happens? This block executes SHM. Okay? With constant amplitude. Executes SHM with constant amplitude. If there is no friction present here and there is no air present, then the block will oscillate with constant amplitude, because work done by dissipating forces in this figure will be equal to 0. Now I am going to define frequency. This will be mean position because normal reaction acting on the block balances gravitational force, and a spring is in natural length. Therefore a spring cannot exert any force. Therefore net force acting on this position will be equal to 0. Therefore this position is called mean position. Here oscillating particle is block and the net force acting on the oscillating particle is 0. Therefore this position is called mean position. Now I am going to define frequency. What is frequency? The number of oscillations, you can say also vibrations, cycles, revolutions, rotations, trips per second. The number of oscillations, vibrations, cycles, revolutions, rotations or trips per second is called frequency. What is time period? The time taken to complete one revolution or one oscillation or one vibration or one cycle or one rotation or one trip is called time period. What is the relation between frequency and time period? We know that time taken to complete one oscillation is called time period. Therefore, in t time, particle completes one oscillation. Okay? Therefore, in 1 second, this will be equal to 1 upon t. which is equal to frequency. In 1 second, the number of oscillations will be equal to frequency. Okay? Therefore, nu is equal to 1 upon T. You can represent frequency like this, or this. This is N, this is F, this is nu. Nu is equal to 1 upon T. Unit and dimension of time period is same as time. Okay? The frequency depends on nature of sources. It does not depend on nature of medium. Frequency depends on nature of sources. For different sources, frequency will be different. Frequency varies person to person. Okay? Frequency varies person to person. Generally, I have observed that the frequency of female is greater than that of male. But the frequency of a child, is greater than frequency of female. Generally, frequency of sound emitted by female is greater than that of male. This is question which asked in IIT in 2002. When a sound wave of frequency 6 Hz goes from air to water, then frequency of the sound wave in water will be, due to change in medium, frequency does not change, but due to change in source, frequency will change. Frequency will change person to person. Here, medium changes from air to water. Therefore, frequency will not change due to change in medium, because frequency depends on nature of source. Therefore, frequency of sound wave in water will remain same as air. Therefore, answer will be 6 Hz. Now I am going to end the lecture today. Thank you. Have a nice day. See you again tomorrow. Namaskar from my side.